Good morning, good afternoon, good evening, everybody. Welcome to another Kemp Technologies Bright Talk webinar. And today we have a great topic and a great guest speaker. So the topic of today's presentation, integrating Kemp load balancing with Kubernetes. So this container stuff and all the cool things that it's doing. And we have with us Barry Gleason, product manager with Kemp Technologies and a true Kubernetes and load balancing expert. And real quick, before I start into a little more, a couple of housekeeping things. So this is on Bright Talk and it will be available on demand after the fact. And as you listen to this presentation, if you have any questions, please put them in the question and answer section of your interface, and we'll be happy to answer and respond to any questions at the end of this presentation. So welcome, Barry. I'm glad that you're back for another webinar. How are things going with you?
I wasn't scared off too much the last time that I'm back. No, thanks a million, Frank. This is great. I always love doing these.
Awesome. And again, today we're going to be talking more about Kubernetes and getting into a little more detail. And then I understand you have some really cool hands-on things in terms of showing how to integrate load balancing technology, which we said in previous webinars. So the viewers, if you haven't seen it, look through our Bright Talk webinars and you'll find one on demand on some previous ones what we've done. Is how load balancing is critical in this application availability, scalability things, and this Kubernetes with all the custom cool stuff it does with containers. It makes sense. And so we're going to do a little deeper dive, technical dive of these things. And Barry, as always, is going to be our resident expert and talk about this Kubernetes and this concept of Ingress controller and what Ingress controller is and how it relates. And let's pull up the slide here for the cover slide. And again, integrating Kemp load balancing with Kubernetes and what it does and how it works, and the walkthrough is going to be really exciting. So I'm flipped to this first slide, and I apologize there, Barry. So go ahead. I'm going to go ahead and hand it off to you. Let you impart your knowledge for everybody, and let's see where this conversation goes.
Cool. Yeah. So I think just to introduce what I'd like to do today is maybe go a little bit deeper in terms of the technology behind an Ingress controller, and specifically how it relates to load balancing technology. So, I mean, I myself would be, I'd be a kind of a networking guy that would have been introduced to Kubernetes from that side. And what I found is you typically have people from a kind of a development type background that have kind of embraced this, this world of using containers and so on. And what we're seeing now is that this, I won't call it a problem, but this whole new way of delivering applications is starting to hit network administrators, and typically the type of people that are looking after load balancing and how traffic enters your network and how applications are delivered. And really, there's a lot of concepts that are common to the two, so that are common to how traffic ingresses Kubernetes and how it can be published versus what people are quite familiar with from the point of load balancing. So what I'd hope to do here is just go through some of the concepts, explain the Kemp Ingress controller, how we can use that alongside our traditional load balanced applications, and run them side by side and together, and even in hybrid environments. And then what I'll try and do is just demo how easy it is to configure on the Loadmaster. Those familiar with Loadmaster will be familiar with what a simple interface we have, and what I just want to show is that this can be extended to encapsulate containerized environments on Kubernetes. So before looking at the kind of integration and the fun stuff of demoing it, I think it's probably worth going through a few concepts pertaining to Kubernetes. So feel free to interject anyone if there's any terms that I introduced that maybe I haven't explained and so on. But there's probably a few that are worth mentioning. So I will refer to containers, and it's probably a term everyone is hearing the whole time, and some people may be a little bit unsure what it is. I'm going to give a very brief definition. To me, a container is basically a small unit of software, including its dependencies, that can be run across multiple environments. So this has really been revolutionary in terms of how software can be developed, because with the, maybe 10 years ago, with the rise in container use, we've all heard of organizations like Docker and so on. What has happened is it's given flexibility for how applications can be architected and created, in that very, very small units can be created to deliver specific components of an application. When we talk about containers, we'll commonly hear the term microservices. They're not the same thing. Microservices is effectively a method of creating applications whereby you split the applications into small components. And the benefits of that is, if a certain part of an application fails or a certain microservice fails, it doesn't cause the whole application to fail. Now, containers themselves lend themselves very well to microservice architecture, because if you're going to split your application down into very small components, having a really lightweight unit of software along with its dependencies, as I defined it, that you can move across environments is really, really handy. So that's, I suppose, that covers containers and microservices. And then the other thing we're obviously going to talk about is Kubernetes. So containers on their own are obviously very useful in that we can create very, very small units of software. But where we are looking to manage a large volume of these, particularly when we're talking about microservices. So imagine what was maybe originally one big application that was deployed on one server. If we want to containerize it and break it up into smaller components, managing that is a new challenge. Now, what Kubernetes is effectively an orchestrator for containers. So sometimes these terms, you're thinking, what's an orchestrator? So the way I would describe it is, what Kubernetes lets you do is manage the deployment of these containers, scale them up and down. So effectively, if you need to grow an application, you can deploy more containers to deliver it. And then if you need to shrink it, you can deploy less. It's typically done by using a declarative file where you can define, I want this particular application to be deployed across using this specific image. I want 10 replicas of it, and I'm going to let Kubernetes be responsible for ensuring that occurs. So if one of these containers fails, for example, Kubernetes will create a new one and deploy it all automatically. So this is really music to the ears to anyone who's managed applications and had to scale them up and stuff like that. One last concept I want to introduce is the concept of a pod. So when we talk about Kubernetes, one of the entities that Kubernetes manages is a pod. And to kind of simplify it, the best way to think of a pod is it's effectively one or more containers that are coupled together. So typically, and in the examples I will show, a pod will just include one container. But in some instances, it's advantageous to be able to couple containers in a single unit of management. So an example might be if you had a container that was implementing some kind of business logic, but you needed to do logging of that logic, it would make sense to bundle those two containers into the same pod from a management perspective. So when you need to scale it up, you'd scale the pod up, and when you need to scale it down, you'd scale the pod down, and it would impact both. So very brief. We could spend hours just talking about Kubernetes themselves. So effectively, there are some of the terms that we'll be looking at in a minute. And I'll stop for a sec if there's any questions.
So that's really cool, Barry. And I do have one question then. So when we talk about taking these applications, and you talked about a little bit of taking these applications and migrating them or transferring them into this container infrastructure and breaking it apart. So I'm going to take this what we would say a monolithic application, legacy application, and I'm going to break it into its subcomponents and spread it across these different pods into these and are the microservices then these little pieces of the application that I'm putting into the Kubernetes, into this Kubernetes container infrastructure?
Yeah, so like to take a very simple example, let's say I had a web-based application, and maybe there's a front-end aspect to it that's delivering a page and that's letting people, interact with what the user sees and images and so on. But then there could be a back-end aspect that executes some code or that executes some logic and so on. Now, we could then have other aspects like a database. We could also have an API that's accessible to external consumers or something like that. So maybe in the past that might have just been created as a single application that's deployed on a single server, that's compiled and that's upgraded and so on. With a microservice application, you could split those down. So you could have the front end, you could have the back end, you could have the database, whatever way you want to do it. And then how that would map to Kubernetes is you would effectively create multiple deployments, one for each of these microservices. And just you can see a slide here. You could, for each deployment, you could have one or more pods depending on how you defined it. So in my example, I could have one deployment for the front end, one deployment for some back end code, one deployment for how we reach the DB. And then depending on my needs, I would then define, and you can see it here, I would then define, you can see here under deployment, I define the images that are used. So that could be the version. So the version of my front end, the version of my back end, the version of my API, the replicas that are needed. Maybe the API only needs one. Maybe on busy days, we need to scale that up. And then effectively the port or the local port that needs to be accessed on the container.
Awesome. That makes a lot more sense for me. Thank you very much.
Cool. Okay, so that leads quite well actually into this slide. So one more thing I just wanted to kind of mention before we get into how the Kemp Ingress controller operates is, so we've mentioned deployments. We've mentioned how with Kubernetes we can effectively define specific microservices that we want to deliver. We define a deployment and so on. Now, that only really is half the job, because a deployment is effectively telling Kubernetes, I want X number of this particular image always to be running. But without being able to actually access these containers, they aren't much use. And when I say access, that could be within Kubernetes. So that could be from, like in my example, from the front end service to the back end service, or it could even be from external. So what's commonly called north-south, or basically where a user needs to access the service. So one very important aspect of Kubernetes is a service. So typically when we are deploying applications in Kubernetes, there's two main steps. I'm simplifying it here, but effectively you create a deployment, which is the first step. And then the second step is you create a service, which is defining how you can access it. So you'll see here there are three native service types in Kubernetes. The first one is called cluster IP, and this effectively assigns an IP address to a service, but this IP is only accessible or only meant to be accessible and discoverable within Kubernetes. So that is obviously very useful if you had, say, a backend that the front end needs to talk to. But if we need to make a service accessible from the outside, we need to use a different type of service. So the second and probably most basic way of accessing a Kubernetes service from the outside is the concept of, or the service type node port. And how this operates is quite simple. So effectively, when you create the service, it will allocate a high-end port, typically over 3,000, in the 3,000 range, or sorry, 30,000 range. And any node within your Kubernetes cluster that is hit on that port number will route the traffic to that particular service. So in this example, let's say the square, you can see there I have pods in the image. Let's say the service for square, you can see that there's a square pod on both of these nodes. It doesn't matter which node I hit, as long as I hit it on a specific port that's linked to that square service, it'll be routed to one of those pods. So that's when people are getting started with Kubernetes, that's sometimes the easiest way of enabling access. But the downside of that is every single service you use is going to have a high-end port for accessing it. So if you're publishing like a web service or something like that, that isn't really it isn't really much good, because you'd have to tell your users that they need to access, port 32061 or something. So the third concept then in Kubernetes, which is quite common for cloud Kubernetes deployments, is the concept of load balancer. Now, this can be confused and kind of misinterpreted as being the same as your load balancer that you would traditionally load balance applications in. The service type load balancer in Kubernetes effectively is a call to action to whatever the cloud provider is to dynamically create a load balancer, a cloud load balancer, and effectively balance across two node ports in the same way as a node port service would do. So in a way, it's kind of an evolution of the node port service type, where you're just saying, I'm going to create the service, I'm going to label it as type load balancer, and I'm going to expect the cloud service provider to see that I'm using a type load balancer, effectively see what node port the service is published on, and spin up a dedicated load balancer for that particular service. So it's quite useful if you're publishing a small number of services, but the downside of it is you effectively need a cloud load balancer for every service that you publish, and it doesn't have any logic built into it in terms of managing based on host name or URL that the request includes. So that's where we get to the next concept. And before I move on, I'll just ask if there are any questions on that. So I'm throwing a lot at you.
So I do have one, and I keep on interrupting you here, Barry, because there's so much good info. But so when you configure, or when a microservice or an instance gets deployed into your Kubernetes cluster, it gets assigned a high random port. So in the traditional world of the monolithic app, I want to publish an app that is a web app. So I'm going to use port 80 or 443 if it's encrypted. That doesn't exist in the Kubernetes and container world unless I'm using this cloud load balancer. So, I mean, it seems like it becomes very confusing then on publishing things for people to access in this containerized world.
Yeah, and that's why the next concept, Ingress, is so important. So, funnily enough, like the node port concept, what we've even seen is before we had Ingress controller functionalities, customers deploying Kubernetes using node port and effectively putting a Kemp load balancer in front of it and just adding those ports as real servers. So effectively the IP address of node 1 as one real server, the IP address of node 2 as the other real server, putting a virtual service on the Kemp load master in front of it, running that on port 80 or 443, depending on what it was, and then that's how they would publish it. So it's doable, but it just isn't very scalable if you had a large number of services, and it would also involve updating and tracking, as you say, these high-end ports that aren't exactly easy to manage.
Exactly. So that's awesome. So yeah, definitely keep on going through this, and look forward to seeing how this all comes together.
Okay, cool. So I'll one more little bit of theory, and then we'll start talking about the and maybe get to the demo and so on. So effectively, I mentioned the term Ingress. Ingress is another layer you could think of on top of this, where we can actually define specific rules about how traffic should be managed and directed to pods. And this effectively gets rid of those issues I just mentioned. Now, you'll see that I've two images here. So I've added that Ingress, it identifies the traffic and routes to the specific pods. Now, there's actually two ways Ingress can be managed. So probably the most common currently would be that an Ingress controller is deployed within your Kubernetes cluster as another container itself. And effectively traffic comes in and just it's almost like you're saying, well, we're going to deploy one service, or we're going to have one deployment, in Kubernetes that's going to manage everything inbound. And then what it's going to do is it's going to examine that traffic and then decide where to forward it onto. And that's how most Ingress controllers are configured, and they've quite a large amount of intelligence in them, where you can effectively have rules based on the traffic type and so on. The most common things will be to look at the host name of the traffic, or maybe the URL. So I could have barry.com is my domain, and then I could have /shop and /reviews, for example. And I could have two microservices, one that is the actual, maybe the shop or the cart or something, and then the second one that is just the reviews of the product. And what the Ingress controller would do is it would examine every piece of traffic as it comes in and then route it to them. Now, that topology works really well. There's a couple of downsides to it. One is the fact that a lot of people will typically put a load balancer in front of it anyway. So what you'll effectively have is a load balancer across the two, or across, in this case, two, it could be a lot more, across your Kubernetes nodes. And then effectively traffic will hit one of the nodes, hit the Ingress aspect of it, and then the Ingress will route it to whatever the pod is. Now, the second topology on the right is where we can perform Ingress external to Kubernetes. So with this configuration, you effectively have a device outside of Kubernetes that will interface with the Kubernetes cluster so that it knows about what's defined and so on. And it will basically take traffic as it comes in and automatically send it to the pods as required. So I would say the advantages of that is that there's some efficiencies in terms of not doing what I call double load balancing, because in the example on the left, traffic may come in, it may hit maybe the node on the left, but then the Ingress aspect of Kubernetes may actually decide that needs to go to node number 2 on the right, in which case you've traffic kind of hairpinning and going in one node, out again, and going to another node. Whereas I suppose on the other side, we effectively take the logic onto the load balancer and then send it directly. So that's kind of a very high level view of Ingress controller. The load, the Kemp load master operates in the mode shown on the right, in which case the Ingress logic is implemented directly on the load master. And what's great about that is it can operate alongside all your monolithic applications. So you can use the same device to manage Ingress or manage traffic across all your virtual services. Really, really nice for network administrators, really, really nice for advanced services where you maybe want one place to do, your SSL offloading, to do advanced access management and so on. And we'll touch on that a little later. Okay, so you can see here, this is just looking at the Kemp Ingress controller. So what we have is the Kemp load master with the Ingress controller installed. And you can see from this, some VSs are just sending traffic to normal servers. So the first one and the third one. And then the middle one you can see is in the same way to the outside world is just another virtual service. But with the logic of the Kemp Ingress controller, what's happening is the traffic is automatically being distributed across the pods to a Kubernetes cluster, and it's automatically scaling based on how Kubernetes scales the application. So if we increase the number of pods or decrease them, the virtual service will react and do that too. Okay, so I'm just going to go through a couple of modes, and then we'll have a look at this in action. So the Kemp Ingress controller operates in 2 modes. So the first one is called service mode. It's probably the simplest really to understand, especially if you're used to load balancing. So with the Kemp Ingress controller in service mode, the steps are pretty easy. We effectively create a virtual service on a load master, and we just note its virtual service ID. So if you're used to load balancing, a virtual service is typically an endpoint that has multiple what are called real servers, and traffic is balanced across these. So in this case, we create the virtual services, but we do not add any real servers. We just take note of the virtual service ID that's used. And then within Kubernetes, if we define a service and label it as Kemp LB enabled, and also specify the specific VS ID, what will happen is the virtual service on the load master will automatically add the required pods as real servers and adjust accordingly when required, scale up and scale down and so on. So this is it's quite simple in that it doesn't have aspects around path routing and host routing and so on. They can be done manually, but it's really, really nice for and what we found is a lot of administrators like the idea of being able to manage Ingress outside of Kubernetes. So if you have a network operations team, for example, that really needs to keep track of, what applications are being published to the outside world and so on, this is a really, really nice way of doing it, because the network in this case, if let's say a development team were looking after Kubernetes, if they wanted to publish a new microservice as part of an application, they could just request that the network administrator would create a VS for them. They would be given the VS ID. They would attach that to the service definition, and then it would all be done. And every time the application scales and things like that, there'd be no need for any updates on the load master and so on. So that's service mode. And then for ingress mode, this is more like your traditional ingress controller. And in this mode, on the load master, you don't actually need to configure anything. So what you're in ingress mode, effectively the configuration is left for what's defined in Kubernetes, and all LoadMaster does is implement what is defined. So in Kubernetes, what you would effectively have is services, deployments created, a service defined as type, typically cluster IP, but then what you do is you define what's called an ingress. And within that, you would have specific details, such as the IP address that's going to be published, the paths that will be sent to specific pods, and you can even add some advanced features on LoadMaster. And then what will happen is on the LoadMaster, the virtual service is automatically created and the real server is automatically added and updated.
So quick question here, yep. Barry. Does this mean, this doesn't mean that Kubernetes needs to understand how to configure the Kemp LoadMaster or load balancer to be able to do this, define the virtual service and everything, but that's the job of the Ingress controllers to take what you configure in the Kubernetes to translate that so that the LoadMaster can be configured properly. Is that correct?
Yeah, if that's exactly, like, you're effectively on Kubernetes, the definition is pretty similar to any ingress, but what you're effectively doing is you're and we'll see it in a second. Your Kubernetes is just defining some ingress rules, send this type of traffic to this app. But what you're doing is you're instructing the load master to execute it. So ingress on its own is actually just a file. It doesn't do anything. It's the ingress controller that kind of implements it. And when you do this, you're effectively saying this Kemp load master, which is outside of Kubernetes, is going to implement all these rules as I've defined. And then when I update those rules, the Kemp load master will react, and it'll, might have to add more paths to the VS. It might have to scale up the real servers and so on, but it's all automatic.
That's really cool. Awesome.
Okay, so before we get to kind of showing some of this stuff, just some of the steps. So typically to get this working, we need to install the Ingress controller. So I'll show that in a few minutes. You effectively enable it within the Kemp LoadMaster UI. You will need to take the kube config file from Kubernetes, and and then upload it onto the LoadMaster. And what that effectively does is gives the LoadMaster the credentials to be able to access Kubernetes and gather the required info it needs in order to do its job, which is effectively manage the ingress. So I'm just going to show you what I'll try and go through. So what we have is we'll try go through a service mode config. So with service mode, I've a pretty simple deployment. One is Apple, one is Orange, and the steps to basically show this will be to create a VS on the LoadMaster, and then create a service in Kubernetes. And in this case, I would need two services, one for Apple, one for Orange. And then you can see there just an example of what the configuration would look like. So the elements there outside of the box, they're just your typical service definition that pretty much all services would have in Kubernetes. And then what's highlighted are the two aspects that you would need. So when you create the VS on the load master, you would note the ID, and then within the service definition, you need the label saying Kemp LB is enabled, and then you need an annotation, which is the VS ID. And then once that's added, what you will see is that the VS will automatically add the pods as real servers and scale and so on. So I'll show that in a minute. And then the second one we'll have a look at is Ingress mode. So with Ingress mode, what you, as I mentioned a minute ago, you do not create any virtual service on the load master. You effectively define everything in Kubernetes, and then the load master will implement that once you apply that configuration. So if you see that example there, I have fruit ingress.yaml. So this is effectively me saying that I want a single service that's going to send traffic to both the orange and apple services. And you can see that there's some annotations like you can see the class is Kemp LB. We can see that the VS IP, VS port, which is effectively how we're publishing it. And we also have SSL acceleration on, which means we're going to actually publish it on a secure endpoint. And then in the spec, we have rules around specific host names and paths that are going to be sent to each of the different services in Kubernetes. Okay, so I'll just see if I can give you a look at this now. Okay, I'm going to show how we can configure the Kemp Ingress controller on the load master. First, I go into my virtual services and go to Kubernetes settings. Here you can see that the Ingress controller is not currently installed. I'm going to click on the install button. All the add-ons and packages are then downloaded from the Kemp Technologies website. So this may take a moment or two. And it's worth noting that you will need connectivity from your load master to the internet in order for it to complete the install. We do have manual install add-ons available on our website too. Okay, so you can see that the Kemp Ingress controller is correctly installed and running. I find it's good practice to do a reboot after we install any add-ons. So I'll just do that now. So we just wait a minute or two for the reboot to complete. So it usually takes a minute or two. In fact, while I'm waiting for that, I can probably complete the next task, which is acquiring the required file from Kubernetes, or what's called the kubeconfig file, which is used by the load master to connect to Kubernetes. So I'm going to go into my own shell here and I'm going to use SCP. So I'm just pulling that from the master onto my local machine. Okay, so I'm going to log into my load master, and then if I go into my Kubernetes settings, and you can see here that I need to add the kubeconfig file. So I'm going to click choose file. I'm going to access that config file that I just downloaded over here, and I'm going to hit install. Okay, and you can see it's already gotten some information already from the Kubernetes cluster. So what this indicates is that the connection from the load master to the Kubernetes cluster is successful, and we're ready now to start configuring some services. So we're going to start off using our service mode operation. And as I said, how service mode works is it requires a virtual service to already be created on the load master. And then when that's done, this this virtual service will automatically adjust its real servers to send traffic to existing pods that have been created in Kubernetes. So it's pretty easy to configure. The first step is to create the virtual service. I'm going to create one with the following address. And I'm going to call this Apple because I want to publish my Apple service. And the thing to note here is the virtual service ID that has been allocated and that I'm using. Okay, so now I'm going to go to my Kubernetes cluster, and I've previously created a file called appleservice.yaml. So what I need to ensure here is that the specific labels and annotations are included in the service definition. So Kemp LB enabled, and then also that the VSID is set to 1 in my case. And then apart from that, all the other information is pretty much what we would use for our most basic service in Kubernetes. You'll also see that the type is cluster IP. Okay, so now what I'm going to do is apply the service. So you can see that that's created. And you can see now I have my Apple service. And if I go back to my Kubernetes settings and load master, you can see that this has been picked up in the services list. And the name is Apple, and you can see that it has endpoints which if I go over here and run the command get pods, I can see that the Apple service has this particular pod. And you can see that that's been picked up as an endpoint. More importantly, however, is if I go into my services here, you can see that the Apple service has a real server that's been added, which is this address. So next, I'll try and access this application. So you can see I've already created a domain name for this. So if I go to the domain apple.bargley.com, and you can see now I'm accessing the app. So basically I'm accessing this service via the load master, which is then sending traffic to the particular pod. And if I want to publish a second service, I can do the same again with a second virtual service. And I take note of the VSID. I go back here. Just make sure that the VSID is correct. In this case, I need VSID 2. So I've now applied that. And then if I go back and view my services, you can see now that the orange one has been updated with the specific pod IP, which maps to the pod over here. And then just to verify that we can actually access it, in the same way I have a domain set up for Apple, I also have one for Orange. And this is going via this virtual service on the load master. So let's see what happens when we scale the service. So if I look at the deployments I have here, you can see that my Apple deployment has just one single pod. And I can also look at this by running the command get pods. So you can see I have one Apple pod and one Orange pod. So imagine that we have quite a lot of users using this particular application and I want to scale it up. So I'm going to scale the Apple deployment to have 6 replicas. So you can see now it has 6, and if I look at the pods, you can see that there are 6 Apple pods running. And then if I look at the services, you can see that the load master has adjusted to show all of these as real service. And that's changed completely dynamically. I can also scale it down. So if I go down to 2 replicas, you can see that this adjusts. So looking at the pods, you can see now some of these are terminating. And then if I go over here, you can see that the number of real servers has scaled. So we'll delete these services now. And also the virtual services here on the load master. And next we look at how Ingress mode works. So over in my Kubernetes cluster, you can see that I still have my Apple and Orange deployments. And then in terms of services, I don't have any services apart from the default Kubernetes one that's there. So in order to operate in Ingress mode, what I do is I configure my services as basic cluster IP services, but this time without the annotations that I used earlier when using service mode. So in other words, when you're using Ingress mode, you don't need those annotations in the service definition. So I'm creating 2 cluster IP services. But what I do need is to define a separate Ingress definition. And I've done this in a file here called fruit.ingress.yaml. So you can see here I've configured quite a number of the different settings, which really define how I want to use these 2 services and how I want them published. You can see that I have 2 host and path rules defined, and these will link to specific Kubernetes service names. So you can see Apple and Orange, and these names obviously must match the services that I just created. So on the load master, I don't have any VS created. And if I quit out of that, and then apply this config and go back over here, you can see that a VS has been automatically created. And then if I just give it a minute, you can see that it's creating the sub VSs that are needed to deliver what we've defined over here. So we have 2 sub VSs, one for Apple and one for Orange. And then just one last thing, because I published this as a HTTPS service, which means a SSL offloading is configured. So I can go in here now and I can apply my own particular certificate to it. Okay, and then in a new tab, I'm going to navigate to fruit.bargley.com. And go /Apple. Or I can do Orange. And you can see I can access the pages for each. Now in this scenario, if I wanted to, for example, increase the amount of services being delivered, this is really easy. So I'll quit out of this one for a second. And I'm going to create the new application. So I'm just creating a new deployment using a new image called pair. I'm publishing it as a cluster IP service. And then if I go back to my YAML file definition, I'm going to add an additional section now for traffic that needs to reach this pair application. So I can simply do a copy and paste job. So I'll paste that in, and I'm going to change this to pair. I'll save it. reapply the file, and now what we should see over here is an additional third sub VS called pair. And if I go up here and type my URL, fingers crossed, now I'm accessing the service that I just created. So that was really, really simple. I created the deployment, created a service, updated my Ingress definition, and the load master updated pretty instantly to include it without any direct config on load master. And then just like before, if I wanted to scale this, that's really, really easy. So I can go into Kubernetes, so let's go mad and scale it to 10 replicas. And you can see now that my pair application is growing and growing. It can take a few seconds. And you can see we have 10 replicas. And then if I scale down, this scales back. Okay, so you can see there's quite a bit of, there's probably quite a bit there. So was there any questions on that? Okay, so next, I just wanted to discuss a couple of other things. So one would be the concept of a hybrid application. Can you hear me, Frank? Hello? Sorry. Okay, guys, sorry, a sound issue there. So I'll just continue on. So one other aspect that I just wanted to mention is when we're looking at basically migrating to microservice delivery and so on, one very common architecture that we're seeing is that specific applications are moving to microservice architecture, but maybe not the whole application. So maybe elements of your application, as I mentioned, maybe your API or your shopping carts are still being managed through monolithic servers, but maybe other aspects need to be moved to a microservice architecture. So just in this slide, you can see that there is, it's very easy to do that with the Kemp Ingress controller. So specifically what we can do is we can set up a virtual service and we can send specific traffic to a sub VS that is configured in the traditional way. But then we can also set up a virtual service that is linked to our Kubernetes configuration. And this is a really, really nice way to manage that migration, and also enables network operations teams to keep, I suppose, to keep control of how traffic enters their network, but doesn't limit them to not be able to use Kubernetes and microservices and so on. Okay, and one other thing that I'd like to mention is that one of the benefits of using the Kemp Ingress controller is the fact that we can use all the advanced services that are included in Kubernetes, or sorry, that are included on Loadmaster for our Kubernetes services. So I think anyone who's worked with Kubernetes will know that sometimes implementing some of this stuff within YAML files and with different services can be quite tricky. Whereas with the Kemp Loadmaster, you effectively have a familiar interface where with a couple of clicks of the button, you can implement things like rate limiting, things like access management. So all pre-authentication authorization, there's even bearer token validation is supported. We can do logging of access and so on. Some typical web performance tools and optimizations such as caching and compression. There's also a web application firewall supported on Kemp Loadmaster. And then even simple things like HTTP header rules and not available redirect rules and so on. So there's actually tons of benefits of managing your Kubernetes application via the Loadmaster, being able to utilize these services and so on. Okay, so that's I think we may have lost Frank, or there's an audio issue. So effectively, that is the end of what I was going to show. In terms of additional resources and follow-up material, we have some great material on the kemptechnologies.com solutions Kemp Ingress controller / Kubernetes page that's listed there, and that will be attached at the end of this beside this video. There's also quite a number of blogs that we've created around the Kemp Ingress controller and demo videos. We've also a feature description guide. So I'd really encourage everyone who's interested to check this stuff out. And just wondering, does anyone have any questions that they can put in the chat? Okay, guys, so really appreciate all your time for attending this webinar. And as I said, please check out those resources, and hopefully this was informative. Thank you.